you need to make sure if you work in this field, maybe in TNB or another company in another country, the maintenance must be carried out properly. Like here, must be clean. Okay, the bushing must be properly clean. Okay, especially if you are very close to sea, where the salt condition and salt can reside on this bushing and makes the current can easily flow through here, okay, to above this the surface of this bushing and then get shorted to the body of this transformer. Okay, as written here, does assist current tracking. We call it current tracking. Okay, so the current can tracking like we go trekking in the jungle. Okay, jungle trekking, right? Okay, so current can also tracking, okay, on the surface of this insulator or this bushing. So we must make sure that it must be properly clean. Okay, this is another view of not clean, not a clean transformer. Okay, this can be a cause of a catastrophic accident. Okay, okay. This one, the oil is already leaking. You can see it by the darken or the black area at the transformer, and this is what it can lead to substation short circuit and leads to fire accident. Okay. Okay, another component is a regulator, which is also a transformer, but with variable ratio. Okay. So this regulator is to make sure the voltage is according to what the customer need. For example, if a customer need 240 or maybe 33,000 kilovolts, okay, so the voltage must be within 5%, okay, 5% of the voltage they need. Okay, so when there's voltage drop, okay, in the incoming, this regulator will switch the ratio so that it can increase the voltage back. Okay, if the over voltage from the incoming, then the regulator will change the ratio so that the voltage will go down. Okay, so it is a transformer. Okay, with oil field transformer. Okay, another component is switch. There's a lot of switch. Okay, as you know, the switch is to open circuit. Okay, but usually is of course is very similar to circuit breaker, but circuit breaker is usually is automatically moved. It can be turned on and turned off, but this switch also to turn on and turn off the circuit. Okay, there are air switch, which is a switch without any insulating component. The air is the insulation, and also oil, vacuum, and septic switches. Okay. Yeah, switches are usually necessary only in very high voltage and high current circuit. So this is some figure showing several type of switch. This one is air switch, typical switch. This is air switch, and this one switch in the oil. So open and close happen in the oil. Okay, this is also another example of switch. Can you see? Okay, here it's here. This is so switch. Maybe the zoom of this air brake switch. Okay, this is how it looks. The air brake switch. The blade and the contact equipped with arcing horn. This is arcing horn. So when it opens, it will be like this. Okay, it will open upside. Okay, this is contacts, which is the moving and fixed contact. So this hand will open. And arcing will follow this arcing horn until it disappear. Okay, I will show you one video showing how every switch open. Okay, this one is a horizontally open air brake switch. If I'm not mistaken, this one is 375 kilovolt line. So when it opens, the current is very high. The arcing will continue for a few seconds before it diminish. This is example of a one pole disconnecting switch to 27 kilovolt, 60 hertz, 600 amp. And we close on the right. Okay, this is a switch for 735 kilovolt, 3000 amps. Okay, this one is not, it's also air brake switch, but it's called disconnect switch. Okay, this switch does not equip with arcing horn. Okay, so means that disconnect this kind of switch only used when the current is already interrupted. When the air brake switch already open. So this is for safety. The next switch to be open. Okay. So we open this air brake switch, then we need to open this disconnecting switch for safety. Okay. So as written here, they must only be open and closed when the current is zero. Okay. Like okay, like this figure, it can be connected with circuit breaker. Yes, first we open the circuit breaker and then we open the disconnect switch. So it must be open when the current is already zero. Okay, this is another example. You can try to look up at any pole, any substation by the roadside. Okay, this one also disconnecting switch rated at 1 kV, 10 kiloamps. Then next one is grounding switch. This is another switch for safety measure to ensure the safety. So after the circuit is open, we need to connect it to ground. So this switch is used. Okay. So when it open, is actually is connected to ground. Okay, it's grounded. Okay, this is example where the disconnecting switch and grounding switch combined, meaning that if the switch is open, it's already grounded. Okay, this is measuring instrument, voltmeter, ammeter, and wattmeter. Relay. I think you know what is relay. So just skip this one. And types of bus bar used. There are many types of bus bar. Round tubes, rectangular bars, solid bars, square tubes, open pair or stranded cable. Okay, used for different purpose. Okay, so this is how the bus bar is used. Okay, it is differentiate with different material. Material is usually thin copper. Size with different size become different current, rated current density, bus bar support, and how to install the bus bar itself, horizontal, vertical, small space or wide space, few space. Okay? So you can see here, this is an example of bar size, bar type, bus bar. You can see when the width increase, you can see the capacity of the current also increase. Okay? And in fact, it becomes thicker when the rating current is 1000 amps and above. And also color coding for the easy identification of the phase. If it is three phase, okay. This is a flexible bar, flexible bus bar. And its support.
Sir.
Ya, ya.
Bus bar dekat sini ni untuk apa sir? Untuk connect current tu ke sir?
Ya, ya.
Ha.
Untuk dalam substation. Dalam substation.
Kenapa dia berbeza-beza sir bus bar dia?
Kenapa?
Kenapa dia berbeza-beza?
Dia beza ikut keperluan. Kalau ruang sempit, mungkin kita tak boleh pakai yang macam ni.
Contoh bus bar ni macam dia boleh adapt ke, macam dia macam line bus bar ni line ke, dia boleh terima current tu berapa?
Dia ikut rating macam dalam gambar ni.
Dia
Table
ada
ni.
rating juga. Okey.
Dia ada rating juga. Tengok current banyak mana. Tengok kapasiti substation tu lah. Substation selalunya dia bergantung pada transformer dalam tu lah. Operating dia. Okay. Bergantung pada size substation. Okay, depends on the size of the substation. Kalau dia besar ke, dia kecil ke, ruang dia tu sempit ke, nak bergerak macam mana, kita nak atur. Sebab apa aku pakai bus bar? Kalau pakai kabel ni dia agak keras, kabel. Okay. Kalau awak nampak ni lembut kan? Lembut. Okay, this is soft cable. If power 3-phase cable is not like this. It's very, you cannot simply bend it like this. Okay, it's not that flexible. Dia ada minimum, dia maximum bend. Okay, jadi kita tak boleh nak senang-senang nak belok-belokkan. Jadi kita pakai bus bar kita boleh bentukkan dia macam-macam bentuk. So, okay. Okay, next one is lightning and surge arrestor. Ada siapa-siapa yang ada pengalaman buat substation punya construction, boleh share lah dengan kita, dengan semua. Itu student last time I saw it was 65 students. Now decreased to 54. With some of you already dropped subject. Okay, next one is lightning and surge arrestor. Jadi, what's the function? The function is to arrest the lightning current, so that the lightning current will not directly flows to the transformer, okay, or to the customer. Okay, as you can see here, this figure, okay, on the right side, where the surge arrestor or lightning arrestor is not used. Okay, so the lightning, which brings very high current, can directly strike this transformer. Okay. However, on the left side, you can see where the lightning and surge arrestor is installed. So the lightning current will be directed to the ground. So it's safe for the transformer. So the maintenance or repair will not be needed. Okay, this is types of lightning arrestor. Okay, usually the lightning arrestor is not directly connected to the gap, okay, to the ground. Okay, as you can see in this figure, it's not directly connected to the ground. Okay, before it's connected to the ground, it is an open circuit switch. Okay, we can see here an air gap. Okay, so when the lightning strike this line, for example, a transmission line or any overhead line, the current is very high, so that this gap will be connected. Okay, so the high current will bridge this gap. Okay, so you can see a spark here. Okay, a spark will be produced here and becomes a bridge. Okay, jambatan. Okay, bridge for the current to the ground. Okay, and before it reaches the ground, there is a resistive element or valve element. Is a resistive, or it's like a resistor. Why we need a resistor here? Why do we need a resistor? Any idea? We have 35 students here. Why do we need a resistor? What happens when current flows to a resistor? Any idea?
Untuk kurangkan nilai current, sir.
Yeah, exactly. Sebab apa? Macam mana current tu boleh hilang? Bila lalu resistor, apa jadi pada current tu? Awak dah pandai ya dah ni. Takkan tak ramai yang boleh jawab. Buka mic. Saya nak recall balik. Apa jadi?
V equal to IR sir.
V equal to IR. Okey, lagi? Jadi apa pada current tu? Dia ubah bentuk kepada apa? Dia ubah bentuk kepada apa?
Loss.
Yes. Okey.
Heat
Dia
loss.
jadi loss. Okey. Dia jadi apa? Pernah dengar joule heating tak?
Tak ada.
Pernah.
Tak pernah saya.
Pernah.
Saya tak pernah.
Tak pernah sir, tak pernah.
Bila current flow, orang pernah buat eksperimen tak? Bila current flow, wire atau kabel akan jadi panas. Pernah tak rasa benda tu?
Pernah tu.
Betul sir, betul.
Kalau
Itu
dia
yang
over-
jadi. Itu yang jadi dekat resistor. Bila current flow, resistor ni dia akan menghalang flow current tu. Jadi panas. Bila panas dia tukarlah tenaga daripada yang ada pada current yang tinggi tu, dia akan tukar pada heat. Okay. Jadi panas. Jadi current yang flow keluar daripada resistor tu kan jadi rendah lah. Joule heating. Sekejap kita cari definition joule heating. Apa joule heating? Okay. Sekejap saya stop sharing yang ni. Kita buka. Awak boleh Google lah kalau pakai komputer. Kalau pakai telefon susah sikit kot. Cuba baca. Okay, saya share. Type je joule heating. Is a physical effect by which the path of current through an electrical conductor produces thermal energy. This thermal energy is then evidenced through a rise in temperature, conductor material temperature. Thus, the term heating is used. Sama juga dengan dapur elektrik. Orang pernah tengok ada dapur elektrik yang tak ada api tu, tapi current flow dia jadi merah.
Pernah.
Benda tu lah. Okay. Gambar. Satu lagi dalam, contohnya dalam lampu. Mentol, kan lampu jadi warna kuning tu sebenarnya mentol warna kuning. Mentol yang kita pakai sekarang banyak LED yang bukan LED tu, panggil apa?
Filament.
Yang pakai filament tu. Itu apa material dia?
Copper.
Apa? Lagi jawapan lain.
Coil sir.
Coil. Bentuk dia coil. Tapi bukan coil lah, coil tu bentuk dia. Dia panggil lampu apa?
Lampu penyok floor.
Lampu benda floor yang panjang tu. Bukan juga.
Set ni yang ni lebih kurang macam apa? Downlight sir.
Downlight tu sarang tu.
Model lama.
Downlight tu kan sarang dia.
Yes.
Tapi awak boleh bubuh lampu dalam tu, bubuh lampu LED boleh. Dia panggil incandescent light. Incandescent light. Ni, nampak ni. Incandescent light. Lampu ni. Ni lampu ni. Okay, jadi selalu orang kata bak putus apa? Dia punya filament putus tu, filament tu ialah tungsten. Ni tungsten. Bila current flow okay, dalam ni dia akan jadi warna merah. Terbakar sebenarnya. Dia macam terbakar. Jadi dia keluar cahaya. Okey. Jadi maksudnya yang ni dia punya R dia tinggi lah. Yang ni panggil incandescent light ya. Kalau yang apa awak sebut tadi? Lampu pendah floor. Lampu pendah floor tu dah bukan yang ni dah, dia lain dah. Yang tu pakai filter lain. Nanti dalam high voltage kita cerita. Okay. Stop presenting here. Okay, present.
So, the tungsten filament dia putus kerana dia terlalu panas ke atau over voltage?
Dia terlalu panas. Lama-lama apa-apa pun bila dah lama panas dia akan putus lah.
Okay, so
Lama-lama dia panas dia putus. Ada soalan? Ya. Present. Window. Okay, jadi inilah yang berlaku what happens to this lightning arrestor. High current akan menyebabkan spark terhasil. Okay. Ada any idea? Awak boleh bayangkan macam mana current tu daripada sini boleh melompat ke sini? Boleh bayangkan, boleh buat apa panggil boleh buat andaian dengan apa-apa. Kalau saya buat andaian macam empangan pecah. Faham? Empangan pecah. Okay. When the water is too the water instantly increase in volume. Okay, so that the dam cannot support the water anymore. The dam will be destroyed. So this is what happened to this air gap as well. Okay, this the feeder, the conductor can hold to a certain amount of current. Okay, I think you already know this in the subject electrical installation design EID. If you have taken it, okay, so a certain size of cable can only be used for certain level of current, right? So when the current is too high, okay, it will find a way to move to the ground. Okay, and here it's moving to all of direction. If it's coming from the left, it will go straight. Okay, and also it will go to this arrestor, and it will destroy this dam. Okay, this is air gap is like a dam, and it will flow through this air gap. Okay, in the form of spark. Spark is a conductor. Okay, spark itself is a conductor. Like in the video I showed you just now, where the contact open, the contact of the air switch, right? Air switch open, you can see the spark. Okay, it's a continuous spark. It's not a spark anymore. Spark is called arcing. Okay, so it is a form of plasma. I think most of you know what is plasma or heard about it, right? Do you know what is plasma? Do you have any idea what is plasma? I think you know three types of state of keadaan jirim. Apa? State of apa? Matter.
Matter.
State of matter, right? Okay. Ya, TV plasma tu. Okay. Jadi, you know state of matter, the first one is apa? Solid, then liquid. Okay. When solid, you increase the temperature, for example, it becomes liquid. And some material directly from solid to gas, right? Solid, liquid to gas. After gas, it is told that plasma is the fourth state. Okay, the fourth state of matter. Okay, after you increase the energy or the for example temperature further, it become plasma. Okay, for example, this gas have 10 molecules. Okay, when it becomes plasma, it becomes ionic state. Okay, it is an ionic state. It become positive and negative charge state. Okay, where the number of positive and negative charge in that state is the same because it comes from the same number of molecules, which is 10. So 10, when it becomes plasma, 10 there will be 10 positive ions and 10 negative ions. Negative ions can be electron or negative ions. Okay, depends on the material. Okay, so when it becomes ionic state, as you learn in chemistry in high school, is not stable. It will find a way to become neutral again. Okay, when it holds charge, it's not neutral. It will try to become neutral again. It will move. That's why it is a conductor. Conductor is a material that can flow current. Why is current? Current. dt. dq over dt. Okay, dq over dt. If you understand calculus, you should know that when you say dq over dt, the change of q over time. Okay, it means that the movement of charge. Okay, it is the current. Or we say current. When charge moving, it is current. Okay. So what happened at the gap is that charge is moving. Okay, in the form of positive and negative ions. So it moves. Okay, to find positive or negative pair and become neutral again. Okay, because it is very high. It is an energetic material. So if we try to move and find positive, we find negative, negative we find positive, and become neutral and release the energy in the form of light or photon. Okay, so there is the arcing that you see. Okay, so the current can flow through this air gap and then directly to the ground via this resistive element. Okay, we will talk further about this in a high voltage part later. Any question? So I think most of you is a final year student, right? Are you coming back to UMP or not?
Tak, sir. Tak.
Tak balik?
Tak boleh.
Tak balik sir.
Tak boleh?
PKPB PKPB, sir.
Oh ramai kena KPP. Yang dah ada kat sini pun ada kan? Tak boleh lalu ah. Pelik juga ni kenapa PKPB ni. Bukan semua negeri patutnya yang kena PKPB ni. Tak tahu, mungkin kerajaan ada justifikasi dia lah. Kita boleh fikir, mungkin kita rasa pelik. Okay, this is how the lightning arrestor looks like. You can see here, this is the high voltage part. Okay, the current will come from here, from top, and this is one gap, first series gap. Okay, you can see here, it's open, first gap. So spark will be produced here first, so that the current, the high current, can flow from this top electrode through this electrode, and then get inside this chamber. Okay, there's another gap again. There's another gap inside this chamber. Okay, and then when the sparks produce again inside this chamber, it will be directed to the ground. Okay. Okay, then this one is current limiting. It's called current limiting reactor. Used to protect the feeder and electrical apparatus such as circuit breaker from short circuit current. Okay, the function is like similar to the lightning arrestor. Okay, to reduce the current, to reduce the, for example, lightning current before it reach the ground. Okay. So I think we stop here. See you in Thursday. Do you have any question?
Not yet, sir. Not yet.
Kalau ada, boleh buat revision, tengok video yang sebelum-sebelum ni. Sekarang minggu ke berapa dah? 4 ke? 5?
Minggu keempat saya, minggu keempat.
4. Selalunya minggu kelima saya dah buat test. Tapi saya tak ready lagi lah test. Tak sempat habis ni. Baru chapter 2, chapter 3 belum.
Minggu keempat sir.
Okay. Tak apa, see you this Thursday. Kami ni pula. Harap-harap
Okay,
saya sihat lah. Okay, stay safe semua. Okay,
Sir, thank you, sir.
Assalamualaikum.
Sir,
Ya.
Sir,
Ha?
yang tadi saya atas sikit. Slide atas sikit.
Like, ya.
Yang tadi current tu egging tu. Ni sir.
Ya.
Yang ni dia nak cakap pasal apa sebenarnya? Dia nak cakap current tu lompat ke sir?
Lebih kurang macam tu lah. Dia asalnya dekat sini, air gap ni dia kita jadi kapasitor kan. Dia buka, current tak boleh lalu. Sebabkan current tu terlalu tinggi,
dia nak buat apa sir?
current dan voltage terlalu tinggi. Okay, current dan voltage terlalu tinggi, dia lompat ke sebelah sana. Daripada atas ni dia lompat ke bawah. Dia lompat ke bawah ni, dia nak ke ground lah. Dia nak ke ground.
Ni lightning ni sebab kilat ke sir?
Kilat pun boleh jadi, apa-apa lightning boleh jadi. Kalau bukan kilat mungkin short circuit, mungkin switching. Bila kita switch on, switch off, voltage tu katakan kita nak 11 kV, dia tak bagi di atas lagi. Mungkin 10 kali ganda. Mungkin 5 kali ganda, 50 kV dia akan jadi. Jadi surge current ni, yang tu dia panggil surge current. Current yang bukan yang kita nak tu. Kita nak tinggi, kemudian baru dia turun. Jadi 11 kV AC. Jadi yang surge current ni lah dia akan overflow. Awak boleh bayangkan current ni air lah. Dia voltage tinggi, current tinggi, dia akan lompat daripada gap ni, ke atas ke bawah. Okay, dia yang daripada atas ni, dia lompat ke bawah. Kemudian dia lalu melalui resistive element, dia akan hilang sebahagiannya sebagai
dia macam loss lah sir?
Panas. Loss lah. Dia loss kat situ. Kemudian yang remaining dia akan flow ke ground lah. Betul.
Ya, kalau
Okey,
dia sendiri current tu ada flow, dia akan continuous ke atau dia to certain timing saja?
Tak clear. Apa soalan? Hello?
Tak sir, kalau dia current sudah overflow, so dia sudah mula jam.
Ya.
Lepas tu dia akan continuous ke atau dia akan berhenti lepas certain timing?
Dia akan continuous sampai ground lah. Sampai habis. Kita tak boleh nampak current tu dan kita pun tak measure current tu. Dekat bawah ni kita tak measure. Tapi kita buat route untuk dia lari. Mungkin current tu dia dah jam, dia dah habis dah tenaga, dia akan hilang terus kat situ je. Kalau dia ada lagi tinggi tenaga, dia lagi banyak current tinggi, voltage dia lagi tinggi, dia akan flow sampai ke resistive element. Dan kalau dia dah habis tenaga kat situ, dia takkan ke ground, dia habis kat situ. Kalau dia dah habis lah. Okay? Kalau tak habis lagi, dia akan ke ground lah. Jadi yang ke ground tu dia dah sikit lah. Jadi sebenarnya dekat bila dah jadi spark tu pun dia dah panas, dia dah buang haba dekat situ. Masa keadaan spark tu. Spark ke arcing. Okay, spark ni sekali. Kalau awak buka lighter dia penyak keluar nampak spark tu kan. Ni kalau jadi arcing dia akan continuous. Jadi sebenarnya apa yang kita sediakan ni ialah untuk dia ke ground. Itu safety. Current tu ke ground ke tak? Dia habis di ground ke, dia habis di resistive element ke, dia habis di air gap ke, tu bergantung dekat dia punya tinggi rendah current tu lah. Current ni memang awak boleh bayangkan macam air lah. Betul kita panggil current tu. Boleh bayang macam air. Air pun kalau dah tangki dia melimpah, dia keluar kan. Ni pun macam tu lah, bila dah terlebih tinggi current, voltage, dia akan lompat. Nanti kita cerita lagi lah untuk air gap dalam high voltage.
Baik, sir.
Okay.
Terima kasih, sir.
Okay, kita sudahi kelas kita dengan tasbih kafaran surat al-Asr.